Everyone's talking about how modern AI has this almost superhuman memory, right? How it can recall any tiny detail from thousands of pages of text. But what if I told you that's basically a lie? That this giant memory we hear so much about is actually just a very clever illusion.
I mean, we see these announcements all the time. Incredible new models with these massive context windows designed to swallow entire novels or huge code bases in one gulp. We just assume that bigger automatically means better, that it guarantees perfect computer-like recall. But is that really what's happening under the hood?
And we're talking about numbers that are just kind of hard to wrap your head around. Some of the latest models can handle up to 10 million tokens of information. To put that in perspective, that's like feeding it the entire Harry Potter series twice. With a memory that huge, how could an AI possibly forget anything? Well, that's exactly where our investigation begins.
So this all feeds into what we can call the myth of perfect recall. It's this common belief that if you just give an AI more context, it just gets smarter and more reliable. And you know what? The industry has a standard test that seems to prove this point, making these models look absolutely flawless. It's called the needle in a haystack test, or NIAH. It's pretty simple. You hide one specific fact, that's your needle, inside a massive document of unrelated text, the haystack, and then you ask the AI to find it. And on this test, the top models score nearly 100%. Case closed, right? Well, not so fast. It turns out this simple test is hiding a really big problem.
Researchers at a company called Chroma have put a name to it: context rot. Think of it like this quiet, creeping disease where the AI's performance actually gets worse and more unreliable the more information you feed it. This is the secret culprit behind the AI's so-called faulty memory.
So how in the world did they figure this out? Well, let's play detective and go through the evidence they collected, because some of these findings are genuinely shocking. It's time to see how these supposedly brilliant AIs start to completely break down under pressure.
All right, our first piece of evidence is the distraction test. The idea here is pretty simple. What happens when the haystack isn't just random fluff, but actually contains things that are similar to the needle you're looking for? Basically, how easily can the AI get confused?
So here's what the researchers did. First, a simple baseline test. Find the needle. Easy enough. Then, they did it again, but this time they added just one piece of information that was related to the answer, but wrong. And for the final test, they added 4 of these distractors. The results were, let's just say, pretty dramatic.
And boom, this chart just says it all. Look at that drop. Just one little distractor caused a noticeable dip in performance. But with 4 of them, the model's accuracy completely plummeted. This proves that these AIs, despite their giant memories, get confused incredibly easily.
Okay, next up is Exhibit B, the structure test. And I've got to tell you, this is where things get really weird. The researchers started wondering if the structure of the haystack itself made a difference. Like, does an AI find it easier to search through a well-written logical essay, or just a jumbled mess of sentences?
So they tested 2 versions. On the left, you have a standard, coherent essay from Paul Graham. It flows. It makes sense. On the right, you have the exact same text, but with all the sentences thrown into a blender and shuffled into a random, nonsensical order. Same info, just zero logical flow.
Now, before I show you the results, what do you think? It seems obvious, right? The structured, coherent essay has to be way easier for an AI to navigate. But the reality was the complete opposite.
Unbelievably, the AI performed better on the shuffled sentences. Yeah, let that sink in for a second. The logical structure of a well-written document actually confused the AI more when the context got really long. It's almost like the AI gets lost in the story, while the random mess is actually easier for it to just mechanically scan.
So let's move on to Exhibit C, the repetition test. This might be the simplest and maybe the most revealing test of them all. The researchers gave these advanced models a task that, honestly, a 5-year-old could do perfectly. Just copy a long list of repeating words.
The prompt was literally just like this: a super long sequence of the word apple with one apples thrown in there somewhere. The only job was to copy it exactly. You'd think a computer would be flawless at this, right? But as the list got longer and longer, the models started to completely fall apart.
After about 5,000 words, one of the models didn't just make a mistake. It basically had a meltdown. It gave up. It literally said it was not in the mood and needed to chill out. This just goes to show that at a large enough scale, Even the most basic repetitive tasks can cause these systems to fail in truly bizarre, almost human-like ways.
Okay, so these lab tests are fascinating, maybe a little funny, but what does it all mean for us, the people who are actually trying to use these tools every day? Well, this isn't just an academic thing. It has huge real-world implications.
Here's the most crucial takeaway. For so long, we've all been obsessed with the size of the AI's context window. But this research proves that's the wrong thing to focus on. What really truly matters is the quality and the structure of the information you give it. Simply dumping everything in and hoping for a perfect answer is a recipe for failure.
And this is where a new idea called context engineering comes into play. It just means you have to be smart and deliberate about what you feed the AI. Put the most critical information right at the beginning. Get rid of any unnecessary fluff that could act as a distractor. And remember what we just saw. That logical flow we humans rely on might actually confuse the AI. You have to guide it to the answer and never ever assume it's just going to find the obvious solution on its own.
So where does all this leave us? It kind of feels like we're in this huge race to build AIs with bigger and bigger memories, but we might be completely overlooking a much more fundamental question about what it means to truly understand information, not just store it.
And this is the thought I really want to leave you with. We are successfully building systems that can hold absolutely vast amounts of data, just like a giant hard drive. But as context rot clearly shows, that is not the same thing as having a useful, reliable memory. The real challenge ahead isn't just making the AI's memory bigger, but teaching it how to actually think critically within that massive space.